All right, problem one, we have the limit of 1 minus the cosine of 2x squared all over 2x squared. So the limit as x approaches 0. Okay, so there's a couple different ways you can do this, but the way I would go about it is just changing the top into the sine squared of 2x. So then we just have this. And that's because if you remember just the Pythagorean theorem, that 1 is equal to the cosine squared of 2x plus the sine squared of 2x. Now for me here, this you can just ignore the squares because with the limit property, this is like just the same as this whole thing being raised to the second power. So I can rewrite this like this whole top, like this whole group into in parentheses all the second power. And then there's this property where if you were by definition, if you have the sine of x over x, the sine of x over x, and you have the limit as x approaches 0, this is defined to be equal to 1. And this is essentially the same thing, but we just have 2x in its place. So this is really just like 1 squared, or just 1 over 1. And so the answer is going to be D. Mm-hmm. And I apologize, my voice is a little raspy. I think I'm getting a cold or something. But anyways, problem 2, it says let f be the function defined above, and what values of x, if any, is f not differentiable. So let's first try to find where it's not continuous. And it's not going to be continuous if the value from one endpoint or from the left side doesn't equal the, so this would be like the negative side, this would be like the positive. If we're connecting these two, and if we're going to connect these two, we want to make sure that these two values equal each other, and that these two values equal each other when you plug in these boundaries. So it's a little hard to visualize if you're not familiar with this, but essentially you want to make sure that the graphs connect at a number line. You want to make sure the graphs connect at -1 and at 2. So you want to plug in -1 into here and here. Let's first see what we get. So we have 2 over -1, which is -2. And we want to get -2 when we plug -1 into here. So we would get 1 minus 3. Yeah, and we get -2 there. So we're good there. Now we want to see that we get the same value when you plug 2 into here and 2 into there. So plugging 2 into there, you get 4 minus 3, or you get a 1. So we want to get 1 when we plug 2 into here, and that would be 8 minus 3, and you would get 5. So it would not be continuous over at this point. So it's not going to be differentiable there. So then it's not going to be B. Yeah, it's what values of x, if any, is not differentiable. Yeah. If x equals, yeah, this is easy then. It only asks is if what values of x, if any, is f not differentiable. So we'll get B. You can go further and check, or you can basically just understand that the definition for a differentiable function, the derivative has to be smooth. It can't be like a sharp kink, and these will be fine. These will all work. So the answer would just be B. All right, problem 3. Table above gives values of the differentiable functions f and g and their derivatives at selected values of x. If h is the function defined by h of x equals all this, then h prime of 1 equals. Okay, so to find h prime of 1, we want to find the derivative of this. So just in general, h prime of x would equal, we're going to use the product rule here. So we're going to have f prime of x times g of x plus f of x times g prime of x. That'll be for that first group. Then the second one, this will just be plus 2 times g prime of x. And since we're trying to find h prime of 1, we just have to evaluate each of these for 1. So f prime of 1, in our table we have f prime of 1 is negative 4. So we have negative 4 times g of 1, which is negative 5, plus f of 1, which will be 2, times g prime of 1, which will be 3, plus 2 times g prime of 1, which will be 3 again. And so we'll get 20 plus 6 plus 6, or 32. And so the answer will be A. Some water. All right, problem 4. Got to find dy dx for this. So here we're going to use implicit differentiation. So we differentiate the x variables just like normal. But when we have a y that we're differentiating, we have to multiply by dy dx. So it's going to look like this. We're going to have 3x squared minus 2, and I'm gonna break this up so we have the product of x, y. So the derivative of x is just 1, so we have 1 times y plus x. The derivative of y is just 1 as well, but we're gonna multiply it also by dy dx. Plus, so we're gonna take that out of the brackets. Ignore this, that should not be messed up there. So plus 3 times 2y times dy dx equals 0. Let me zoom up a little bit. Okay, so cleaning this up, we get 3x squared minus 2y minus 2x dy dx plus 6y dy dx equals 0. So I'm going to subtract this, bring this to the right side. So this will go away, and we'll get this equal to negative 3x squared plus 2y. And then here we're going to factor out the dy dx. So we're going to have dy dx times negative 2x plus 6y. Let me switch colors here. And then from here, we're going to divide by this negative 2x plus 6y. Negative 2x plus 6y on both sides. And so this will be our final answer. And that's going to match up. It's going to look, it's not in this form because for whatever reason, they like to write it in a different way. So they moved around this negative symbol. But the answer is going to be B, because you can take this negative 1, and redistribute it, and it's going to be the same as this. Or number 5. The radius of a right cylinder is increasing at a rate of 2 units per second. So let's start off by writing dr dt is equal to 2. Since it says units, we'll just leave it as 2. And I assume that everything is in terms of seconds, so no worries there. The height of the cylinder is decreasing at a rate of 5 units per second. So dh dt will be -5 because it's decreasing. And we want to find which of the following expressions gives the rate at which the volume of the cylinder is changing with respect to time in terms of the radius r and height h of the cylinder. Here's the formula for the volume of the cylinder. Okay, so let's differentiate this using the chain rule. We're gonna have dv dt is equal to, let's keep the pi factored out for now. And we're gonna have product rule with chain rule. So r squared, that'll be 2r dr dt times h. And then we're going to add this to, this time leaving the r squared as constant. R squared, the derivative of h is just 1, so it's just 1 times dh dt. And so now we just have to fill in the dr dt and dh dt with 2 and -5. And so we'll get pi times 2 r times 2 h plus r squared times -5. So factoring this all out, 4 pi RH plus a -5 pi r squared. And so the answer is just going to be C. All right, there you go. Hope that helps.